Number 4. Nonconformities, corrective actions, and even preventive actions. Hello everyone, thank you for watching this video that will give you an idea about how I work and make a relationship between nonconformities, corrective actions, preventive actions, measuring and monitoring. Initially, we had in mind a fourth video about quality policy and objectives and its relationship with strategy, but an email asked me to treat this topic before. My name is Carlos Pereira de Cruz, my background is chemical engineering, and after 8 years of working in the industry, I started a career of almost 25 years as a consultant, trainer and auditor around ISO 9001 and ISO 14001. Later, I developed a special interest in the balance scorecard that I frequently use a lot together with ISO 9001. We continue to see quality management systems that treat every nonconformity with a corrective action, at least according to their wording, because when we check those corrective actions, we see that they are no more than simple corrections after all. With this presentation, we want to share our approach about how we connect nonconformities, corrective actions, and even preventive actions with measuring and monitoring. We'll use a set of 4 diagrams, 4 figures, to systematize my thoughts on these topics. Let's start at point A. At cruising speed, we measure the quality of products, for example, during quality control activities. We measure to make decisions. So we compare the actual result of measuring with a specification. The result of this comparison is recorded and can be, according to the results, we are okay with the standard, with the specification. So, in a winning team, don't move. The other result is nonconformity. Oops, we have a nonconformity. We have to deal with that nonconformity. Treating a nonconformity involves eliminating it. The activities to be developed may include avoid unintended use of the nonconformity, analyze nonconformity to decide a destination, rework, correction, disqualification, or downgrade, use as such, scrap, etc. And implement a decision and confirm the implementation of the decision. Is the correction done? If no, start again. Record all these steps and decisions made. These activities are usually performed under the pressure of the stopwatch. You have to decide and implement as soon as possible. Many companies state in their procedures and forms that they identify the cause of nonconformities during the nonconformity handling phase. However, our experience tells us that the vast majority simply identify the reasons for the nonconformity. Few identify the causes. Because the causes are usually hidden, they are not easy to find. Sometimes the investment required to identify the true root causes of nonconformities, investment in time and human resources, has an insufficient return. So, most companies do not identify the causes of nonconformities during their treatment phase, and that's okay. I often associate the challenge of identifying the causes of a nonconformity with the inner appearance of an onion. The root cause is, like the onion's core, hidden under several layers. Normally, it's not easy to find causes. It's not cheap to find causes. So, we have to focus our scarce resources for when it is really important to find the causes. For example, the figure identifies a number of reasons that led to the nonconformity delay in scheduled surgeries. At this stage, companies typically do not identify the causes of nonconformities. This only starts when we ask why. Why do patients not follow instructions? The main reason for delays in scheduled surgeries. We don't need to go after each and every reason for the nonconformity. We just need to focus our attention in the vital few. From here, let's go to figure 2. Once closed, once the nonconformity has been dealt with, now, without the stopwatch pressure, we ask, is it necessary to improve? That is, are we facing a systematic problem, a serious problem, or just a punctual problem? Depending on the answer, we are showing our confidence or distrust about the current working method. If we think the current method is still valid, we go back to point A in figure 1. There is no place for corrective actions, actions that attack the cause of the nonconformity. That is, we agree that we have a standard, that we must continue to follow it, that we must continue to monitor and measure it, and act accordingly. The SDA cycle, the cycle of control. But if we think the current method is no longer valid because we are facing a systematic or very serious problem, then we have to change the system. We have to take corrective action, an improvement action, and go to figure 4. We use the metaphor of the bridge because we have to make a transformation, a change in our system. As we decide that improvement action is needed, we move out of the SDCA cycle, the cycle of control, the cycle of daily control, of process control, and move on to the improvement cycle, the Deming cycle, the PDCA cycle. Back to figure 1 again, independently of the measurement result being conformity or nonconformity, periodically performance should be monitored. So, let's go to figure 3. Regardless of the decision to improve or not in sequence of an isolated result, conforming or nonconforming, organizations periodically produce reports that compile performance, where we can see evolution and trends like in a movie and not just frame by frame. Once these reports have been prepared, trends must be analyzed and decisions made. Can we live with the current level of performance? If so, we don't need to improve performance. We still consider the current standard as useful and valid, and we go back to figure 1. If not, if we want to improve the current level of performance, we need to develop a preventive action, an improvement action. That is, switching from control mode, SDCA, to improvement mode, PDCA. So, let's go to figure 4. Here's an example of data analysis in a periodic report. The organization prepared the monthly control chart for activity rate, a productivity measure. According to this moving range chart, there are no significant departures in terms of variability. The moving range chart reveals that there are no noticeable causes in the system, no statistically significant differences detected from month to month. But the individual chart, the one below, reveals that there are important jumps around the average value, a signal that there are special causes operating in the system. When the organization looks into what is behind loss of performance, it starts with facts, with symptoms. The yellow boxes mark production changes. Whenever there is a product change, production must be stopped, lines cleaned, equipment change, raw materials change, preparing production, starting production, approving production. The orange boxes mark problems with raw materials, quality problems or delivery delay resulting in lack of raw materials for production. Green boxes represent equipment malfunction and machine breakdown. And the blue boxes mark lack of people. Production stops due to lack of people to produce or change production. Let us focus our attention on the problem with raw materials. Why do we have problems with raw materials? Production stops for defective subcontracted parts. Production stops due to lack of subcontracted parts. Production stops due to lack of raw materials. A team found these cause-effect relationships. So, production stops for defective subcontracted parts because we accept deliveries with defects. Because subcontractors deliver orders too late. Because we have a high level of non-conformances in subcontractor deliveries. That results in we do not transfer the losses generated by subcontractors to subcontractors. And so, we do not pressure subcontractors to improve their performance. And subcontractors deliver non-conforming orders because we select subcontractors with negative history and we do not control subcontractors during production. And we select subcontractors with negative history because we do not evaluate the performance of subcontractors and we do not systematically search potential subcontractors. And also, we select subcontractors with negative history because we do not have time to choose subcontractors, because we place orders upon the event, because we do not control stocks of raw materials and finished products, because we do not use our computer system correctly, because our computer system has gaps, and our warehouses are disorganized and lacking storage. Also, die delivery time is always longer than order because we have a weak bargaining power. That way we subject ourselves to not having the best raw material prices. So we dilute purchases and we work with multiple vendors just in case. Because we do not have procurement and supplier planning, because we have no market consumption forecasts and we don't have raw materials consumption profiles. If we want to reduce production stop due to problems with raw materials and other supplies, we have to remove these root causes. Figure 4 illustrates the steps of developing a corrective or preventive action. Let's call it an improvement action. We have to collect the data, like using Pareto diagrams, using graphics, using figures, using control charts. We have to determine the causes. We have to define the action. We have to implement the action and check effectiveness and update the standard. So when proposing an action that is implemented and which is effective, we can move back to the process control mode by updating the standard, the work methodology. We go back from the improvement cycle, the damming cycle, into the control cycle. The action is update the standard, the A to the S, and return to figure 1. If you have any question about nonconformities and improvement actions, you can send me an email. Our next video will be about the quality policy, quality objectives, and strategic direction. How does the strategic direction influence your quality management system?